This is Brian Putt. Previously, I posted a video about consolidating SME assessments, but I used two triangular distributions. Today, I want to augment that by taking two random SME assessments, as shown here, and consolidating them and showing two different ways how they can be consolidated, and then comparing the two results. So the two results are: one, pick a percentile and average that value. That's probably a way that some people will do it. The other way to do it is to pick a value and average the percentiles. And so we want to ask the question, which is better? And that may be a subjective decision rather than objective. We're going to focus on picking a value and averaging the percentiles, because I believe that's the best way. So here are the two assessed distributions. You'll notice that one has 5 data points, and the other has, 7? And the percentiles don't always match up. So how are you going to consolidate those into one subject matter expert assessment? Okay, here's the process, methodology. We want to start by obtaining those assessments from multiple SMEs. Now, I'm only going to use 2 here, but you could use multiple, more than one. That's or more than 2, no problem there. And then you're going to fit each of them to a metalog. I just simply use, because these assessments typically have a percentile and a value, we use the generalized metalog file available from the metalog distribution.com, I believe it is. And for each one of those, you can calculate the mean and the max of the assessment from the metalog. And you calculate the mid of the max assessments. And from those two values, you then can calculate a value between the mid and the max. So why do you want to do that? Well, let's go back one here. No, we haven't gotten to that yet. Once you have those values, you can calculate a P. You can calculate a P for each of the metalogs using this random variable that goes between the min and max, and then average those P's. And that'll fit the values and the P's to a metalog using that same generalized metalog model. Let's flip over to the model. Okay, here's the model. And the two SME assessments are over here. Here's SME assessment 1 and SME assessment 2. And I fitted each of those to a metalog. This one was used a 5-term semi-bounded metalog. And this one used a 4-term semi-bounded with a lower limit of 0. These two charts show in orange, the actual data points, and then the metalog distribution. Now, if you don't like that distribution, there's others you can pick from. I decided that was the best I could do given the 5 data points. The second distribution, I was able to fit much better, having more data points. It kind of showed the curve. So you can see that. So now we have these two metalogs of our two distributions, and they are reflected here. And we can plot those two distributions here. This is distribution 1 and distribution 2. You might come back here and ask, well, why did I take the maximum of the minimums and the minimum of the maximums? Well, you can see that if I tried to assess a percentile for the value 200, I'd find it for metalog 2, but not for metalog 1. So really the values I'm going to assess are between this number here to this number here, okay? Those are the only values where I have I can get percentiles for both distributions. So I'm going to do that. And then I'm going to average those percentiles. So here's for this particular value of 46. So 46 would be right around in here, okay? It says that for distribution 1, it's 66%. And for distribution 2, it's only 11%. Right through there. And that averages to 38, 39%. So now that I have a value and a percentile, I can fit those values to a metalog. And that turned out to be a bounded 6-term metalog with a lower bound of 0 and an upper bound of 250. I can then plot that over here. We can see the two distributions and the fitted metalog. But I want to ask the question, how does that compare if I just average the values for the same percentile? Well, when I sampled these two metalogs, I used the same seed, meaning that I sampled the same value, okay? These are the weights. So here I sampled, that's the seed. I guess it doesn't show me the percentile, but they're the same percentile that I'm sampling. And then I can get the average of whatever number that is. And it turns out to be 52. If I went to a different trial here, now it's 46. That's 79. Got the idea? So from that, I can plot this value and the percentile. How did I do that? Well, I did do it. And it's shown down here. Well, first of all, let's come back here to our method of picking up a value and calculating the percentiles and averaging those. Here are the two distributions. This one goes from 0 to 350 or 300. So what I've done is I've expanded that to look at this one. Look here. To only go from 0 to 100. Because beyond that, they're pretty much the same, right? They're getting pretty, we don't need to look at these differences. So at a value of 40, one person is saying it's around 55, and the other person is saying it's around 8 or 9. And I compromise and say that it's equal to 30. Now, how does the other method work out? Over here, I have plotted the two distributions. So this is that taking a value and weighting the percentiles. And this is taking the same percentiles and weighting the values. The question is, which one of these is better? It's a reasonable question to ask. And to be very honest, if I was just looking at this graph, I might say that this lighter orange one is the better one than the darker orange. But let's once again blow this up. And now I'm looking down here. So let's look at that same 40. So once again, if you asked the subject matter experts, what is the percentile for 40, which is kind of a reasonable way to ask the question, and one said 55 and one said 8 or 9, would you compromise at 30? Or would you compromise here at 15? It seems like your bias is towards the gray SME, or that the gray SME is distribution 2. So that shows a difference here in these two assessments. And I'm not saying that there's always the same hammer is the best one. So in other words, always picking a value and averaging the percentiles may not always work right. I can't say that for certain. So maybe you want to do both of it. the way I've calculated these in this model, I do get both of them. This is the one where I'm averaging the values for the same percentile. And down here is where I've averaged the percentiles for the same values. So if you're interested in this model, I'd be happy to share it with you, along with the supporting Metalog distributions where I fitted those. Thank you for watching my video.